Hey everyone, Dan here bringing you the next installment in our series of guided practice problems. Today we're looking at balancing redox reactions in acidic media. So here is the reaction that we want to balance. Notice if we try to balance this using conventional means where we just put coefficients in front of each one of these reactants and products, we hit a roadblock pretty much immediately in the form of we have hydrogen on the reactant side and no hydrogen whatsoever on the product side. So there's no way that we can balance this just by adding coefficients. In cases like this, you're going to need to use something called the half reaction method, and that consists of 7 easy steps. The first step is going to be taking this overall reaction and breaking it down into 2 half reactions. And you'll see that I've done this by taking out the things that are similar on both the reactant side and product side and putting them together in a half reaction. So I have everything that contains chromium in this half reaction and everything that contains nitrogen in this half reaction. So that's the first step, just breaking down your overall reaction into half reactions. Once that's complete, you can move into phase 2. So the second step is balancing the non-hydrogen and oxygen atoms. So you're going to do this on a per half reaction basis. So in this first half reaction, I have 2 chromiums. I need 2 chromiums on the product side, so I put a coefficient of 2 in front of the chromium 3 ion. Fortunately, the only non-hydrogen or oxygen atom that I have in the second half reaction is nitrogen, and that's actually already balanced. I have 1 here and 1 here. So that's part 2 complete. The next step is to balance oxygen atoms by adding water. So you have to remember that this reaction is taking place inside acidic media, and that's an aqueous solution. So we have lots and lots of water, and it turns out that this reaction actually uses that water as a product and reactant for these half reactions. So water's participating in this reaction, and we're going to introduce enough waters to balance out the oxygens in both of these half reactions. So notice in the chromium half reaction, I have 7 oxygens on the reactant side, so I need to introduce 7 water molecules to give me those 7 oxygens on the product side. Next, I look at my nitrogen half reaction and total up the oxygens on both sides. Turns out I have 2 on the reactant side and 3 on the product side, so I add 1 water molecule to give me a total of 3 on both sides. But by doing this, notice that when we add a water molecule, we're also adding in 2 hydrogen atoms, which, though we had that in our second half reaction, we actually didn't have any hydrogen whatsoever in this chromium half reaction. So now we're going to have to balance out the hydrogens, and that is step 4. We're going to balance hydrogen atoms by adding H+ ions. So again, this is happening in acidic media, so we have a bunch of water molecules. We also have an abundance of hydrogen ions because it's acidic. So we're going to add in enough hydrogen ions to balance out the hydrogens on both sides. So in this chromium half reaction, I introduced 7 water molecules. 7 times 2 is 14 hydrogens. So I have 14 hydrogens on the product side. I need 14 hydrogens on the reactant side. So I add 14 hydrogen ions here. In the nitrogen half reaction, notice I already had 1 hydrogen on this side from the HNO2 and 2 hydrogens from the water molecule that I added in the previous step, for a total of 3 hydrogens on the reactant side, and I had none on the product side. So I added 3 H+ ions to the product side to balance out the hydrogens on the reactant side. Alright, so at this point, we have all of our atoms balanced. The next step is going to be make sure that we have charge balance. So step 5 is to balance the charge by adding in electrons. We know that when we're talking about redox reactions, we're really talking about an exchange of electrons. So if we total up the number of charges on each side of each one of these half reactions, we'll notice that on the reactant side of the chromium half reaction, we have a total of a plus 12 charge, because we have these 14 positive charges and then 2 negative charges for a total of 12. And then over on the product side, we have 2 times 3 is 6. Water is obviously neutral, so we have a total of plus 6 on the product side. So we're going to get these sides equal to each other by adding enough electrons to the more positive side to bring it down to match the less positive side. So the more positive side is the 12, less positive is obviously the 6. So we're going to add 6 electrons to the reactant side to make it so that both sides have a plus 6 charge. And that's what this would look like down on the bottom. So we have 6 electrons added over on the reactant side, and that gives us our plus 6 charge on both sides. We do the same thing for the nitrogen half reaction. Notice over here we had all neutral species, so we have an overall 0 charge. Over here we have a -1 plus a +3 for a net +2 charge. So again, we're going to add electrons to the more positive side to bring it down to match the less positive side. So we're going to add 2 electrons to the product side to give us a neutral charge on both sides. So you can see that I've added the 6 electrons and the 2 electrons over here, and now both of these are charge balanced. Now that we have charge balance, we can proceed to step 6, where we're going to make the electrons lost equal the electrons gained. So the electrons that are being given up in one half reaction have to be taken on in the next half reaction. So you can't just have electrons materializing out of nowhere. You can't have them just being destroyed. So the number of electrons lost must equal the electrons gained. And the way that we're going to ensure that that is the case is take a look at the number of electrons that are on the reactant and product side in the 2 half reactions and make sure that those 2 numbers are equal. So in this case, we had the 6 electrons that we introduced on the reactant side and the 2 electrons that we introduced on the product side. We want to make those equal, so the least common multiple between 2 and 6 is going to be 6. So I'm going to take the second half reaction, the nitrogen half reaction, and multiply through by 3, and that will give me the 6 electrons that I need. So I'll rewrite this, and notice I have, once I distribute that 3 all the way through, I have the 6 electrons on the product side and the 6 electrons on the reactant side. Once those are equal, we can proceed to the final step, and that is just going to be to add the balanced half reactions back together. So notice when we do this, anything that we have in the same exact quantity on both the reactant and product side, such as these electrons, will get canceled out. So 6 electrons on the reactant side, 6 electrons on the product side, those cancel out. And then any like terms we have are either going to be combined or canceled. So combined if they're on the same side, which in this case we don't have any, or canceled if they're on opposite sides. So 3 water molecules on the reactant side will cancel with 3 of those 7 water molecules on the product side for a net of 4 water molecules on the product side. And then the same is true for the hydrogen ions that we added. We have 9 hydrogen ions on the product side and 14 on the reactant side. So 9 will cancel out with the 14 to give us a net of 5 hydrogen ions on the reactant side. Once we've taken into account all the things that are either going to be combined or canceled, then it's just going to be a simple matter of combining everything that's on the reactant side, writing that all together, and then taking everything that's on the product side and writing that all together. So what I'm left with is 5 hydrogen ions, which I brought down here. We have the dichromate, excuse me. We have the dichromate anion, which I brought down here. We have the 3HNO2, which I brought down here. And that's it for the reactant side. Then we jump over to the product side. We have the 2 chromium-3 ions brought down here to the product side. We have 4 H2O molecules down here. and we have the 3 nitrates also brought down here. So once you have all of that combined, I guess it wouldn't hurt to double check to make sure that it is in fact balanced. I won't bother because I know it is, but if you go through and total up all the hydrogens, chromiums, oxygens, etc., you'll find that they now are the same on both sides. So that's it really for the half reaction method. If you follow those 7 steps, you really almost don't even have to think about what you're doing. I know that's a strange thing to advocate for, but if you follow these 7 steps, you really can't go wrong balancing redox reactions. So again, to recap, the steps are 1, to write out your half reactions, 2, balance your non-hydrogen and oxygen atoms first. Once those are balanced, you can jump to step 3, which is balancing oxygen atoms by adding H2O. The next step is to balance the hydrogen atoms by adding H+. Then you can balance charge, adding electrons. Step 6 would be making the electrons lost equal the electrons gained. And then finally, once you've done all of that, you can just simply add the 2 back together, making sure to combine like terms or cancel things that are on opposite sides. All right, so that's pretty much it. Catch you in the next one. If you have any questions, feel free to come to office hours or send any of us an email. Have fun.